Hi, my name is Maman. I'm a PhD student at Tel Aviv University under instruction of Amit Bermano. I will now present our work Typenet towards camera-enabled touch typing on flat surfaces through self-refinement. We've developed a system that enables touch typing on arbitrary flat surfaces and requires only a simple camera. The camera is located in front of the user's hand and the user can type on any flat surface while the system detects the text that's being entered. Our method relies on standard touch typing where each key is pressed by a certain finger and has a distinct hand configuration and motion that's associated with it. Our system learns to detect and classify these configurations and motions while also leveraging temporal context. One of the central benefits of our approach is that it allows free and uncalibrated typing that's not constrained to specific or carefully considered key locations. Therefore, in addition to tolerance to finger drift, our system also allows the user to change the location of the hands or even the alignment between the hands, and this does not affect performance. Previous works are mainly before deep neural networks. They either do not allow natural typing speed or they require additional equipment such as 3D sensors or marked gloves, and some operate from less practical camera angles. In our system, as I've mentioned, detection is done from the front. This is an angle that's practical for mobile usage. So our key insight is to directly classify raw video frames rather than estimated hand pose, since classification of discrete hand configurations is much easier than continuous hand tracking. If we try to classify estimated hand pose from some off-the-shelf hand tracking system, accuracy is much lower, as can be seen. And since the configurations and motions that our system detects are common across users, our system allows interaction with multiple users, as can be seen here. So how do we train our system and how do we collect data for the task? It seems that there's no straightforward way to automatically annotate surface typing. So we break the process into three phases. In the first phase, we train a network to detect keyboard typing, where we can achieve the annotation automatically using the keyboard press and release events. But this is not sufficient because there are significant differences in typing style between keyboard typing and typing on general surfaces. So we still need to somehow annotate surface typing. So how do we do this automatically? We record users typing texts that we provide to them on flat surfaces. So we know the text that's being entered, but not the precise timing of the key presses. This is a weakly supervised setting. We then use dynamic time warping to compute the optimal alignment between the known text and the probabilities predicted over the video frames by the initial network from phase 1. We avoid possible user typing errors which might occur by discarding singular points of the computed alignment. And this way we obtain a frame level annotation also for surface typing, and this is done entirely automatically. This is the self-refinement phase, and it's a central component of our method, since it allows to easily collect more data. Once we've obtained a frame level annotation for surface data, we can add it into our train set and further improve our network. This is phase 3. Our dataset contains typing from 26 users, approximately 25 hours of keyboard typing from all users, and approximately 6 hours of surface typing from 10 of the users. These are the users we evaluate our system on. At inference time, we apply a custom real-time language layer based on beam search. We maximize the sum of the vision score and the language score, where the language score comes from an existing character level language model. Mean accuracy over the 10 users is 93.5. These are users the system is familiar with. For a new user, mean accuracy is 85.7. It's lower, and not surprising, but it's still promising given the small number of users in our dataset. So the main direction for future work is generalization to new users, and we believe that with larger datasets, this can be achieved. Thank you.